In this lesson, we're specifically going to talk about quadrilaterals that are parallelograms. First, before we get into the new information, I want you to take a look at these two triangles. So instead of writing a two-column proof, just to save a little bit of time, I want you to explain how, given the information, you know that these two triangles are congruent. For example, side angle side, angle side angle, angle angle side, hypotenuse leg, etc. In number 2, first show me that the two triangles are congruent, and then show me that those two pieces are congruent to one another. So go ahead, pause this video, and tell me or write down what you think. Alright, on that first triangle, MN is congruent to PO, and NO is congruent to MP. That's our given information. Now, the second step of this proof would be that this line NP is congruent to itself by the reflexive property. Therefore, we have three sides congruent to one another in the two triangles. So these two triangles would be congruent by side, side, side. So that'd be a pretty short proof, about 3 steps. Now this second one's a little bit longer, so I'm going to go ahead and mark the given information. AB is congruent to CD. AB is perpendicular to BD. Well, if AB is perpendicular to BD, that means it is a right angle, or a 90-degree angle by definition of perpendicular, and same for CD and BD. Now, hopefully you see these, it's kind of hard to see, but these two triangles overlap each other here on BD. So they would be congruent to one another. So I'm going to go ahead and mark that. So by side angle side, the two triangles are congruent to one another. Therefore, if the two triangles are congruent, that means all of the parts are congruent. So AD would be congruent to BC by corresponding parts of congruent triangles are congruent, or CP, CTC. Like I mentioned before, we're going to talk about the specific properties or the special properties of parallelograms. So first we've got a couple theorems. If your shape is a parallelogram, then the opposite sides are congruent. So the parallel sides are congruent to one another. Also, if it is a parallelogram, then the opposite angles are congruent. So if angle Q is 100 degrees, angle S would also be 100 degrees. Alright, I want you to go ahead and try out these examples. I know we haven't done any about parallelograms, but I think that you can figure it out given your algebra knowledge and those couple of theorems. So go ahead, pause the video, and figure these out. Alright, so in number 1, setting up the equation to solve for the value of x. Now maybe you did that mentally, totally fine, I'm okay with that. But we would have x plus 4 equals 12 because the opposite sides, or those two parallel sides, have to be congruent. Therefore, the value of x is 8. Now the value of y, angle A here, has to be the same as the measure of angle C, opposite angles theorem, so y would be 65. That angle would be 65 degrees. For number 2, segment FG would be 8 because it is opposite of HE, and HE is 8. And angle G would be 60 degrees because it is opposite of angle E, so they would have the same value. And then number 3, the value of x, by setting up this algebraic equation, our opposite angles would be equal, so 2x equals 50. And again, you might have done that in your head, totally fine. But if not, that's how we'd set it up algebraically. Divide by 2, x is 25. And then lastly, our opposite sides must be congruent, so 18 is equal to y plus 3. Solving for y would make y 15. Now the last unique property that we're going to talk about today is the consecutive angles theorem. So for a parallelogram, any two angles that are consecutive, so in a row, so like here, y and x, or maybe you want to go here, y and x, as long as they're in a row, they are supplementary. So that means they add up to 180 degrees. Now think about that. Like our last theorem said about the opposite angles, if my opposite angles have to be 100 degrees, well, they don't have to be, but if they're the same, let's say they're both 100, well, I could figure out those other opposite angles. So 360 degrees is how many are in a quadrilateral, minus, I've already used 200, that leaves me with 160, and I have to divide it evenly between those two remaining angles. So 160 divided by 2 would make these 80, and we can see that 180 adds up to 180. No matter what angles, maybe you got 47 and 133, it doesn't matter. Any two angles in a row add up to 180 if it's a parallelogram, and that comes from the consecutive angles theorem. So I want you to go ahead, try this problem, and figure out what the measure of angle BCD is. So pause the video, try it out. Alright, hopefully you saw that these two angles are consecutive. So if ADC is 110, I can't quite squeeze it in there. I'm looking for angle BCD. So this angle, they are in a row together, so they would add up to 180. So 180 minus 10, or 110 would be 70 degrees. So the measure of angle BCD is 70 degrees. Alright, for this next one, back to the proofs. Just what you wanted, I know. So take a minute, look at the given information. How can we prove that angle BC, or angle B, is congruent to angle F? Just think about it, try to write it down. So hopefully you're thinking, well, because it's a parallelogram, the opposite angles are congruent, so B would have to be congruent to D. Well, these are vertical angles, so those would be congruent, and D and F are congruent because it's a parallelogram, so opposite angles, right? Well, if they're all equal, then B and F are equal. But how to write that out in steps? Alright, so I'm sure we all got the given, but step 2 is just like I verbally explained. So angle CBA is congruent to CDA, because they're opposite angles of a parallelogram. And EFG, I'm going to use 2 marks because I don't know for sure if it's congruent, is congruent to EDG by the same reason. That's why I listed them in the same step. Well, I know that these two angles in the middle have to be congruent because of vertical angles. So I'm going to go ahead and write that down. Like I mentioned when just talking through it, if all 4 of those angles are congruent, we can eliminate those middle 2 and say that angle B and angle F are congruent to each other. So by looking up here, since this is congruent to CDA, and CDA is congruent to EDG, and EDG here, we're getting rid of all of those overlapping pieces. And we are left with angle CBA, which is also known as angle B. If you'd rather just write angle B, that's fine. Is congruent to angle EFG. Or angle F if you'd rather just write angle F. Now how do we know that? Well, we got rid of all of those overlapping pieces. That is the transitive property of equality. So there we go. We proved that those opposite angles are congruent. All right, we're going to go ahead and pause there. We'll finish 7.2 in another video.